just gonna double check that everything is good in the live stream. 1 second. So it says here that I'm live. Now I'm just gonna double check here that everything is like good with the video and the audio. That I'm live. That's good. I'm just gonna double check here that everything is like good with. It's perfect. So let's go. So as you know, we finished the 2 first courses, which is like working with the OpenAI API and the prompt engineering with OpenAI API. We finished the project. It's a really small project, and now we're gonna go with the 3rd course, which is working with HUGGINGFACE. So let's go right into it.
Hi, and welcome to this course on Hugging Face. My name is Jacob H. Marquez, and I'll be your instructor. Hugging Face is a platform where the AI community can access, collaborate, and stay informed on the latest open source models, datasets, and applications. And you don't need to be a machine learning engineer to use Hugging Face. The Hugging Face Hub is a centralized place where you can find the best models for your project, download datasets to train or fine-tune your own models, and build applications, all in the browser. If you do want to use Hugging Face in Python, they provide libraries with extensive documentation for everything, from exploring the Hugging Face Hub all the way to training models and deploying applications. We'll use some of these libraries in this course. All of this is made possible due to the thriving community around Hugging Face, where people openly share and contribute their models, datasets, applications, and integrations. This isn't just a community of individuals either. Many of the biggest organizations building AI right now, like Google, Meta, and DeepSeek, are openly sharing their latest models and research developments on Hugging Face. If there's a dataset you've compiled, a model you've fine-tuned, or an application you've built, consider open sourcing it and sharing it on Hugging Face so the whole community can benefit. In this 2-hour course, you'll learn to navigate the Hugging Face Hub to explore and use models and datasets. Doing this both in the Hub and with Hugging Face's Python libraries. We'll use these to perform common natural language tasks like summarization, classification, and document question answering. Note that this course is the first in a series of courses that go on to cover Hugging Face for LLMs, including prompting and fine-tuning, other modalities such as images, audio, and videos, and efficient model training. So stay tuned. Let's dive into the Hub by exploring an example. Imagine we're looking for a text generation model, which we plan to fine-tune to our company's proprietary data to create our own internal chatbot. We would navigate to the model section of the Hub and select the text generation task filter. From here, we can browse the latest, most downloaded, or trending models that support this task. Within each model, there is a model card, which provides handy information that can help us decide which model to choose. Each card has the model name and the user or company that uploaded it to the Hub. It has the tasks that it's able to perform and the different modalities it can work with. There's also useful information on the languages the model is trained to work with and licensing information. Elsewhere, it commonly includes the model's intended use and limitations, its training parameters, the datasets used for training, and its evaluation results. We can use these evaluation results to compare it to other models as we explore the Hub. We may also find research papers attached to the model card if we want to read more about the training process. Once we've found a suitable model, we can begin testing it. We can click this button, which gives us a few choices on how to run it. The Transformers Python library from Hugging Face provides code for loading these models for inference or training. Inference here simply means prediction. For text generation models, this is the prediction of the words following an input prompt. There's also the option to create notebooks with this Transformers code pre-populated. Finally, there's an option to load and serve this model with VLLM. VLLM is a popular choice for application developers looking to serve AI models in a fast and memory-efficient way. In the next video, we'll talk more about how to actually run these models using either local hardware or Hugging Face's inference providers. See you then.
All right. Just in case, I'm gonna enter now to the Hugging Face. Hugging Face. I'm just gonna log in. 1 second. All right. So I'm just filling out the form. So Okay, I created. Now I need to verify my email. Give me 1 second. I'm just not showing this part of the screen because it's private. Alright, confirmed. Now I have access to HUGGINGFACE. Okay, I'm gonna come back to share my screen now. Yeah, and let's come back here. HUGGINGFACE is a powerful platform that provides many benefits for building AI solutions, simplifying workflows and making advanced models accessible. Following is not the benefit of using HUGGINGFACE of building possible answers. So it's not access pre-trained models. It's good. So this is not guaranteed model performance and end support for ML workshops. So it is engaged community. It is end-to-end support for ML guaranteed model performance for consult task. This one is not guaranteed. It explore. Exploring models on the hub. You are a research scientist working on a new type of X-ray image devising. This device offers increased image resolution, which you hope to use to detect illness like pneumonia earlier. Rather than training a machine learning model from scratch, you want to find an existing model trained for a similar purpose to your new images. On the model card, which model is shown. Okay, this is the model card of this model that I might pick. Okay, this model is a fine-tuned version of Google. This is a classification that achieves the following results: evaluation, loss, accuracy, transformers, towards safety and such as screen related to the okay, and so it's image classification, so it's good. By user X1, this is also correct. The model can also be used for image generation. The model, I think this is not, it's not generation, it's classification. And the Apache 2 license is good. So I guess it's just this one. Okay. Running Hugging Face model. All right.
Great work exploring the hub. Now let's see how we can begin using Hugging Face models. When running models, in other words, predicting or performing inference, there are two main options. Using our own local hardware to run the computations, either on our physical computer or laptop, or inside our cloud-based development environment. Or using an inference provider via Hugging Face's API. These inference providers are partner organizations that provide remote access to high-performing machines. We send a request to an inference provider with the desired model and inputs. The provider runs the computations, and the result is returned back to us. Running models on local hardware is free and convenient, but for some consumer-grade hardware, running inference on some models, particularly large parameter LLMs and image video generation models, can be slow and resource-intensive. Inference with these models really requires the use of graphics processing units, or GPUs, that aren't included in many consumer systems. In these cases, switching to an inference provider is recommended. They can perform inference much quicker than we could on our own, without burdening our own hardware. It's free to get started with inference providers, with some credits provided to Hugging Face users. Let's look at how to perform inference using both of these methods, starting with local inference. The Hugging Face Transformers library simplifies working with pre-trained models, both for inference and training. The Transformers pipeline is a convenient class for quickly performing local inference for any of the models and tasks available on Hugging Face. First, we import the pipeline class from Transformers. Then we instantiate it, specifying the task we'd like to perform and the model we'd like to use. In our example, the task is text generation, and we've chosen OpenAI's GP2 model. Remember that you can find the model name and supported tasks on the model card on the Hugging Face Hub. We'll call our pipeline on the string whatifAI to see if the model completes it with newly generated text. It returns a dictionary with the generated text found under the generated underscore text key. We can make adjustments to the pipeline output using different parameters when calling the pipeline. For example, here, we limit the output to 10 tokens, which are groups of characters processed by language models. We also request 2 generated sequences rather than just the one we got before. This will produce a list of dictionaries like the one we saw before, so we'll loop over it to extract the generated text. There we have it, 2 short generated sequences to our input. Now to try out Hugging Face's inference providers. We create an inference client, which configures our environment for communicating with the inference API. Within this client, we specify the inference provider we wish to use. and our Hugging Face API.
So just in case in this part, first we showed like how we can import into our local machine and run it. And because it's a probably really small model, which is GPT-2, then we can run it. But in the inference provided is the way that we can run this model in some external machine that actually have the capability to run these models, which is the case when the parameters are too huge, are too resource intensive, and is going to run really slowly in your machine, or is not going to run at all because your machine doesn't have the capacity.
AI key, which will be used to access and use our inference credits. Here we've opted for Together.ai as our provider, but there are many others to choose from. We'll have to go at performing text generation with a conversational interface this time, which is a common way for prompting most text generation models. This involves sending model inputs as messages, which are models this time, which is a common way of text generation with a conversational interface.
So you see, here is like doing a similar way that we were doing it with the OpenAI client, that we were importing the client from OpenAI, and then you were creating you were importing the OpenAI provider, and then when you were creating the client, and then if you see here, you do practically the same, the structure. Just like you create the client, the completion is created, you send the model, and then you send the messages.
Sending model inputs as messages, which are a list of dictionaries. Each message is sent from a role. For model inputs, we use the user role. This is our request to the inference provider. Accessing the generated text, we can see that the model responded to our input, which didn't put any strain on our own hardware. Now it's your turn to begin inferencing with Hugging Face models.
Noise. So it was in transformer, import, pipeline. So I'm just gonna take the hint here. And the pipeline should be text generation. So it should be 10 tokens. It should be two outputs. It's called the pipeline. And then I'm gonna run it into here. I'm gonna make a new one, which is gonna be hugging face. See the hugging face, and then here I'm gonna touch one initial setup. I'm gonna change it to Python file. Then in here I'll just copy this. Then I assume that I'm gonna run Claude. I'm gonna clear this. Then if I run this, of course it's gonna throw an error. I'm just gonna, yeah. So I need to, I guess I need to run pip install transformers. Okay, so I'm gonna do this on this file. I'm getting this error. Oh, no, it's fine. Okay, fix it. Probably it's gonna tell me that I just run pip install. I just wanna see how it rolls because I think I have the Python version. I have the 3.11. I guess if I run it, it should be okay, and it should generate already the answer. Yeah, and the answers are here. I'm just gonna make sure that I can run this. Okay. Wait 1 second. Okay, it's just the command to install. Missing library. And this is gonna be really important because I have a few projects that doesn't really require like super complex. For example, customer support tickets for, I don't know, hospitality are not extremely complex tasks, so you don't need like a super advanced LLM with millions of parameters, with billions of parameters. Then for those tasks, I guess that I could just use one of the simplest models. This so I'm getting these. Transformers with S. Okay. What does this library does? It's a Hugging Face main part. Okay, so this is the library Hugging Face. Is with this you can call the models from that are available there. I guess you can run locally with a couple of lines code. The pipeline function is the security. What's everything? Tokenizer model versus frozen. So it's a wrapper that can be multiple functions called independently or sequentially, but this pipeline simplifies the call. Just need the task and the model, and it handles the rest. So I guess that at some point, if I create some certain model, when I upload it to Hugging Face, I can just modify. I can define the tasks and the tasks that model can do, and then when someone wants to call it, then that person can define the task that it's gonna perform with my model. Uh, okay, so if now, okay, I see it. So I'm getting some errors on the. Okay, it's a warning just. Okay, these are just warnings. So I guess not this. Still no. Uh-huh. Let's have the rights to write the pigmentize. So it was installed per user. So I guess that I need to install it in the user too. And then if I want to install it system-wide, I need to run it via the administrator. Again, transformers. Hmm. It's taking a while, huh? So I submit this. Let's continue. We're in the 4-day streak. That's cool. I mean, while we wait until this is installed, in some cases you might like the hardware running Hugging Face model local LLMs and image in particular require graphics processing GPUs to parallelize computation. Hugging Face provided inference. Okay. Direct the code snippets to the correct order. So first you import, then you create the client, then you get the completion, and then you print the choices. Okay. So I install it. Let's see how it rolls. I hope it can it can run my machine. Mm-hmm. So here it is probably downloading this model because at the end I first just imported the transformer, the pipeline. I installed the transformers library, but I didn't install this, so probably it's just downloading right now. That let's just wait and let's.
Welcome back. Now that we've found and used models from the Hugging Face Hub, let's become acquainted with the datasets. The Hugging Face Hub provides a collection of community-curated datasets across a variety of tasks and domains. Under the Datasets tab, we can find the most suitable dataset for our purposes by applying filters, very similar to what we did with models. Let's see an example. We're looking for an Italian text dataset to fine-tune a text generation model to improve the quality of the Italian it generates. To find a suitable dataset, we first select the text modality. Then, under Tasks, we select Text Generation. Within these filter datasets, we can perform keyword searches to narrow the results down further. This top one looks promising. Each dataset has a dataset card, which, like model cards, contains key metadata like how it was compiled, the license it can be used under, the number of rows, and more. The dataset viewer allows us to preview the rows to get a feel for it, but for a more detailed look, we can use the Data Studio. Finally, we can manipulate the dataset using SQL queries. Here, we use a where clause to filter the dataset and the like keyword to find rows containing the word bella, which is beautiful in Italian. Once we're happy with our dataset, we can move to Python to begin working with it. As with transformers, Hugging Face developed a Python package specifically for interacting with datasets, and it's called datasets. The datasets library allows us to access, download, use, and share datasets with minimal lines of code. To download the dataset, we use the load_dataset function and provide the dataset path. We can use additional parameters like split to specify partitions to download, such as train, test, or validate, which are used for developing and evaluating ML models. Check the dataset card to see which partitions are available. Most datasets in Hugging Face use Apache Arrow, which is a data format that leverages columnar-based storage instead of more traditional row-based data storage for faster querying. Manipulating Arrow datasets is slightly different from other data structures, like Pandas data frames. To filter, we use the .filter method with a lambda function that applies the defined criteria to each row. For example, we're again checking if the string bella is in each row. To select rows from an indices, we use the .select method. For instance, select range 2 retrieves the first 2 rows, leaving a dataset with 2 entries. To review a specific entry in the slice dataset, pass the row index, in this case 0, in the column, in this case text. We've covered a lot about datasets. Now it's time to put this into practice.
All right, exploring datasets on Hub. Hugging Face Hub is home 100,000 of datasets across domains, languages, size, and modalities. Designed to help altruism about math problems. Okay. Which one of those following statements are true? There are 4 million rows. Platform, yeah, it's here. It's available under the MIT license. Or here's the license, MIT. It contains images, text-to-text generation, so it doesn't contain. The dataset is called MATX. So it doesn't contain images, so it's false, and the MATX 5 million. So it's correct. Okay. Let's see if it's still downloading. This is gonna be a really issue because I think we'll need to always use an inference provider for any of the models we have. Let's just ask Cloud when I run this. It is stuck. Can you please analyze why? Because maybe I need to create an account or put a token somewhere, or maybe there's something I don't know what's going on. After you've chosen your dataset, it's time to load with the datasets library. So I need to first load dataset, and then here I need to put this library, which is here, and then set the split parameter to validation. Okay. So now do this to data set. And this is gonna be dataset setup. And this is gonna be from transformers import dataset. So it's running the local model. Okay, so let's run this in another. No, it's in learning. let's run this command so I can see if we're actually downloading any model. So yeah, it's 313. So probably it's missing 200 megabytes. So next time that I want to see the progress, I need to run this. If I run it again, stuck in 330. Let's wait for a few minutes, and if it's still stuck in 330, then we can come back to it. Then, okay, then for the second one, which is the second fault, which is I'm gonna import this data set and just the validation, and let's just go into it to see how it rolls, how it looks like in real life. And probably again it's also downloaded. So at least it's not throwing error, so probably it's downloading, because if it will be throwing error, I'm getting this. So it is throwing an error. So it's coming from a different library then. And as far as I remember, from datasets, import load dataset. So this is the correct one. And then if I run this, I shouldn't have this error. And now I'm having this, because I also need to import this library. I need to install it. What is this library? Datasets. I mean, I need to install it, but hopefully this is also some library from HUGGINGFACE. Yeah, it's another HUGGINGFACE library. So now I have two libraries from HUGGINGFACE. One is the transformers library, in which we can import the pipeline, in which we can run local models. The other one is the datasets library, in which I can load the datasets from that are open source there. Cool. Oh, nice. So first of all, I'm installing. Second of all, I see that I already have that model downloaded, and I can see that it created the answers. So now we're running GPT-2 locally, and it works good. Let's submit this. Okay. For using with, then there will be likely many occasions when you will need to manipulate a dataset before using it with an ML task. Okay, yeah, because I will not use the whole dataset, but just a fraction of it. Or filtering and selecting. Oh, before, normally you do this in SQL. Given the size of datasets, greenhouse layers are of file types. Okay, so perform manipulation are slightly different than you want to use. For example, there's already methods to help with this. The dataset is already loaded for you under Wikipedia. Okay. So here I probably need to do filter. Be that filter, and then I need to find in the text column. So I should filter all of the rows in which the column text. I should keep the all of the rows in which the column text has this football text. Select a single example. So answer should be this. So I should use select and then run. Yeah, so I selected just one of the answers. So this is gonna be 3 and data set selection. So I'm gonna do this. Can you please expand the coding here? So we import a data set from HUGGINGFACE. So now what I'm trying to do is I am trying to make the cloud to expand this code, so we do the import. So maybe something like this, and then I need to do something like this, but it's gonna find me a library. Yeah. It's filtering the documents in the column text and explaining. So this is like a simple one because for English it's 2 gigabytes and I don't have that space. You don't want to unload this connection. Yeah, that's correct. So I don't import the model because I'm just importing data sets. No. So I'm gonna say, can you explain deeper these 2 lines? In correction machine. Okay, this is instead of answer filtered. So it's asking me to create this variable like exactly like as it is. Which soccer player born made Luis Miguel Aparecido Alves. Yeah. So I finished the chapter 1 of getting started with HUGGINGFACE. Then we'll run into chapter 2. I'm just gonna finish with the explanation here. Filter goes through a data set by row and keeps only the rows that pass the test you provide. And one function default volume row. So it's a simplified way to do this. Is a new dataset containing full mention in the original Wikipedia and touch if the original has. Again, select dataset containing only rows that positions just for. Takes a list or range of row indices, not a count. So that process sequence 1, so it will take you to the third row. So if you range find, you get the first 5 rows. Select 0, 10, we grab those. Okay, specific row. So you can specify the list with the indexes. Okay. Okay, that's good. So we finished this. Our first call with the local GPT-2 model worked. Here I'm gonna run the sorry, I was muted. I'm just trying to make sure that if I run this, like, if I run this script number 2, I'm not gonna fill my machine. This one is tiny. Okay, now let's stop. I mean, here I will just like run and print the data set. So I will just run Python 2. Wait, what? I forgot to ask. Very little, that one is tiny. Okay, I'm gonna ask how tiny. I forgot to ask that. It's only 70 questions. Okay. 0.1 megabytes. Alright, that's good. And then the third one. And this one, I'll just get the training split from the dataset. What about this script? But I'm not just the training split. I'm not downloading the full one, I'm just downloading the training split. Aha. Shit. Okay, it doesn't matter, I'll just let it be. And then I'll just delete it. Anyway, that's all for now. Let's take a break and let's come back later because I also need to walk the dog, take breakfast, and have a business meeting. Thank you very much, guys. Then in the next live, we're gonna go with the second part of working with HUGGINGFACE. It's gonna go with more advanced concepts. So let's jump into it after. So